In our last video, we looked at vertical shift transformations of functions. In this video, we're going to look at horizontal translation or transformations that shift our graph horizontally. So this time, let's consider a couple of functions here. I have f of x equals the absolute value of x, and g of x equals the absolute value of x minus 2. So this is a little bit different. In the last video where we talked about vertical translations, we said that there is some constant on the outside of this. What happens when we pair that constant that we're adding on or subtracting off with the x? So in order to investigate this, what we're going to do is going to make a table of values and talk about what we discover as we put in these values here. So let's go ahead and put in our x here. We're going to refer to this one here as f of x, and f of x is just our parent absolute value function. So we have some v-like thing we'll see here, but we say g of x really is just the same thing as x absolute value of x minus 2. And so we'll take a look at this. And so we'll go -2, -1, 0, 1, and 2. And so start with your absolute value here. Absolute value of 0 is 0, absolute value of 1 is 1, 2 is 2, but absolute value of -1 is just a positive 1, and the absolute value of -2, when we plug that in, is a positive 2. So what this does is it casts our parent function, which we are already aware starts at 0, 0, and goes through 1, 1, and looks like a V, so we also know it has y-axis symmetry and is even. And these are the 5 points that we had graphed right here. Okay, so what we want to do here is we want to actually graph this, and I do mention up here, go -3 to 3, and I forgot to do this. So we'll do that here, 3, and I'll have to add in a 3 and a 3 here. So those go on my graph as well. But what we want to do now is find g of x, where g of x is the absolute value of x minus 2. So I'll actually plug this in over here. Let's start with -3, but if we said g of -3, what this would mean is the absolute value of -3 minus 2. We get the absolute value of -5, which comes out to be 5. So we say 5. Let's plug in our 2 here. If we had done the absolute value, let's say g of -2, we'd get the absolute value of -2 minus 2, which is the absolute value of -4, which is 4. We could guess that if we plug in a -1 here, we'll just go ahead and do this, -1 minus 2 here, we would get an absolute value of -3. We get 3. So 3. When we plug in 0, we get the absolute value of 0 minus 2, which is the absolute value of -2, which is 2. If we plug in 1, it's getting interesting, more and more interesting here. We say the absolute value of 1 minus 2 is the absolute value of -1 is 1. So we get 1 here. And then when we plug in 2, finally this happens. We get 2 minus 2. Absolute value of 2 minus 2 is absolute value of 0 is 0. And then our very last one, if we plug in a 3 minus 2 inside the absolute value here for 3, we actually get 3 minus 2 is 1. The absolute value of that is 1. So going and graphing all of these points, and I'll try to cast these. Let's do it like an orangey here. Orangish. We could say that we get these points here, -3, 1, 2, 3, comma, 1, 2, 3, 4, 5. And then we have -2, comma, 4, -1, comma, 3, 0, comma, 2, 1, comma, 1, and then we had the point 2, comma, 0, and then finally the point 3, comma, 1. And what I want to do is I want to sketch this in, knowing that, by the way, because it's an absolute value graph, it must still look like a V. But the whole point of this video is to determine what changes and what is the same about these two functions here, f being our first function and g being a transformation of that function. So we say, well, what's the same? We have the same shape. We're preserving the shape, but what things are different? We have a shift. And if I were to say, well, how did it shift? We shifted g 2 units to the right of the parent function f. We can see that all of the points move 2 units to the right. And one might speculate the reason why is because we have this -2 right here. Now, counterintuitively, you would think that -2 would shift it 2 to the left, but actually shifts it 2 to the right. I guess my question is, if there were another function then, h of x, and I said, well, h of x is just the absolute value of x plus 1, where this plus 1 is in here with the x. I still think that this will probably affect my x values, that is, have a shift left or right, but because this -2 in here caused our graph to shift 2 to the right, I might conjecture that this goes left 1. And as a matter of fact, you can make your table of values, you could extend this table of values to do that, but what you'll see is that it certainly indeed would take this graph here, h of x, and it would shift all your points left 1. So instead of starting at 0, 0, it'll go left 1, then start at 0, 0, go up 1, right 1, and then have this V-like graph right here. So we would say that this is h of x here in green. Okay, sorry about that left side. So we say, what statement in general could be made about the graph of a function g of x in relation to f of x if this is true? G of x is really f of x plus c. So the interesting thing here is this. Remember up here that f of x was just the absolute value of x. And here we got g of x is the absolute value of x minus 2. What I really want to point out is g of x could really be said as the same thing as f of x, where instead of x we plugged in an x minus 2 in for x here instead. And so when I talk about f of x plus c in here, you'll notice that in our last video we were talking about what does the effect of f of x plus c or f of x minus c have. And that c is this constant on the outside. But whenever you have this constant on the inside here, you can see that it's directly involved with the x value here. What we actually get is horizontal shift. And so we're going to summarize it thusly. We would say that horizontal shifts, letting f be a function and c being some positive real number, we say the graph of y equals some parent function where we plugged in a plus c with our x. What this does is it shifts our graph left c units. It's the opposite. We'll make a note here. Opposite shift. And so essentially what we're seeing is if we add c onto our x values, it shifts it c units left. If we subtract c units off of our x values, it's going to shift it right c units. And this illustrates both of these instances. If our parent function is this black one right here, y equals f of x, then to add c onto it, shifted it c units to the left. And if we have our black function here, f of x, and we say, well, this is f of x minus c, we would go c units to the right. So using this idea, what we want to do is we want to use the graph of the parent function of the square root function to obtain the graph of g of x, which g of x is just the square root of x minus 4. So first things first, let's graph the parent function. The parent function here goes through 0, 0, and 1, 1, and it is the square root function. So I'm going to say that if you do not already have this memorized, and I don't care, I want you to make a table. You know what? That's your bad. Until you memorize it, you have to make a table. So what I'm going to tell you is I chose some convenient values to plug in here since it's a square root function. But the square root of 0 is 0, so we get the point 0, 0 here. And the square root of 1 is 1, so we got 1, 1. But also the square root of 4. The square root of 4 is 2. So I would go right 4 up 2, and that point would be here. And then right 9 would take us up 3 since the square root of 9 is 3. And so if this is 4, we got 5, 6, 7, 8, 9. It'd be somewhere in this neighborhood. But here's our parent function right here. I'll try to make this. There we go. It's like half of a sideways parabola. So here's our f of x. What we wanted to do is sketch the absolute value, the square root of x minus 4. And using what I already know, I noticed that this minus 4, it's not on the outside of the radical. If it had been, then this would have been a vertical shift downward 4 units. Because it's in here with our x's, then it's going to shift it horizontally 4 units. And even worse, we would say, because it's negative, it looks negative at least, it's actually going to go 4 units to the right. So for instance here, I would grab every point. I would say instead of starting at 0, 0, it's going to go 4 right, start there. And it would have gone through 1, 1 before. And that's like up 1, right 1 from here. So we would say, well, then now I know it's here. And I know this point 1, 2, 3, 4 units would go 4 units right there. And so we could say that this right here is the graph of g of x. And it's really just a horizontal translation 4 units to the right of f of x. Cheers.